This video is on polynomial and rational inequalities. So basically, polynomial and rational inequalities are relatively simple to do. We're not going to worry so much about solving them, and we're not going to worry so much about the signs, but rather we're going to look to see if we can find the roots, which are the x-axis or the x-intercepts, and any domain exceptions. So that's going to be for things like these rational inequalities where they have a denominator or could possibly have wholes. Once we find all the roots and domain exceptions, we're going to plot them on a number line and test points to decide which regions are included, and we'll write our answers in an interval notation. So the first thing we want to do is we're going to look at a polynomial inequality. So this is actually a quadratic inequality because quadratics are a type of polynomial. And the very first thing we want to do is we want to move the 15 to the other side of the equation. We want it to say less than, greater than, less than or equal to. We always want it to have 0 on the opposite side. So now we have 2x squared plus x minus 15 is greater than 0. So what we want to do is we want to factor this. So I'm going to set up a little factor tree here. So I know 2 and negative 15 gives me negative 30. So I know 5 and negative 6, or 6 and negative 5. And I want it to add up to positive x, so I'm going to use the 6 and negative 5. So now I have 2x squared plus 6x, and then I also have another parenthesis of negative 5x minus 15. Now I'm not going to worry about writing the greater than 0 part because we're really concerned about finding where the intercepts are for this graph or for this problem. So I know that I can pull a 2x out. That leaves me with x plus 3. And I can pull a negative 5 out from the other side. That leaves me with x plus 3. So I have two parentheses, x plus 3 and 2x minus 5. And if I want to find their intercepts, I set them equal to 0. This gives me an x-intercept of negative 3 and an x-intercept of 5/2, which is really just 2.5. Now, from here, once we have these intercepts, we want to put them on a number line. So I'm going to go ahead and graph a number line right quick. Okay. Here's my simple number line, and I'm going to put a couple values on here. Negative 3 is probably pretty important. We normally like to plot 0 on here, and 2.5 or 5/2, however you'd like to write it. So from here we want to decide what we should have at negative 3 and at 2.5. So that's where this sign is going to come back into play. Notice that this does not have an equal to bar, so neither of these points are going to be included in our answers. So we should have an open circle at both of them on our number line. Now we want to test points. When we test points, we're going to go back to the original equation. So we're going to maybe test, how about negative 5? So if I do 2 times negative 5 squared plus negative 5, I want to see if this is greater than 15. So negative 5 times negative 5 is 25. 25 times 2 is 50. 50 minus 5 is 45. So I have 45 is greater than 15, which is true, which means this all should be part of my answer. So I have everything to the left of negative 3 so far as my answer. Well, now I want to test this middle section. So I'm going to test 0 now, since it's in between negative 3 and 2.5. So I have 2 times 0 squared plus 0 should be greater than 15. This time, notice I have 0 is greater than 15, which is not true. So I know that this section of my number line is not part of our answer. And lastly, we want to check on something that's greater than 2.5. Let's just go with 5. So now we're going to do the same thing. 2 times 5 squared plus 5 is greater than 15. So again, we have 5 times 5 is 25, times 2 is 50, plus 5 is 55 is greater than 15, which is true. So we want to include everything to the right of 2.5 as well in our answer. So for our final answer, we want to write down the parts that are shaded. So remember we always write things from left to right. So we're going to start here at this arrow. So I have negative infinity to 3. And since this is an open circle, I get a parenthesis. Union, open parenthesis, because this is a circle, 2.5 or 5/2 to infinity. And this would be my completed answer. So my intervals, or the sections that I can test, would be from negative infinity to 3 and from 2.5 to infinity. Now if you'd like to use your calculator for this kind of problem, we can do that. So again, I've plugged in my equation so where I have everything on one side of the inequality. Now when I graph this, I still have no idea what needs to be graphed. But remember the whole point here. We're now looking for the part of the problem where y is greater than 0. Remember, greater than 0. Well, y is greater than 0, everything above the x-axis. So notice that this part is above the x-axis and this part is above the x-axis. But this part is also above the x-axis. So how do I decide which parts should be part of my answer? That's why it's so important to test those functions. So we know that it's this section out here and this section out here. And if you think about it, if this section had been part of my answer, all of this would also have been part of my answer, because it would have been weird to shade part of the parabola and not all of the parabola. So in this case, we're just shading the outside of the parabola, which is part of my answer. So let's go back and look at our other problem. Our other problem is a rational inequality, and it has a fraction, which is how I know it's a rational inequality, and we're going to do the same kinds of things. Remember that when we use RADI, the first step in RADI is to set the numerator equal to 0, 3x plus 3, and solve. So I have 3x equals negative 3, and x equals negative 1. So now I have one part, or one number, that should go on my number line. Now I also have this 2x plus 4 on the denominator, and this is going to be my domain. Remember, I can't have the domain equal 0. So I know that 2x plus 4 cannot equal 0. So therefore 2x cannot equal negative 4, and x cannot equal negative 2. So we know two things. We know that x cannot equal, or x equals negative 1, so we should know this is going to be a dot on our number line. And we know that x cannot equal negative 2, so this should be an open circle on our number line. So let's make a number line. So we're going to draw our number line here. And we should, of course, have a couple values. In this case, we have negative 2, we have negative 1, and I always like to put 0 on here. So again, we're going to come back to these points, and at negative 1, we should have a dot. At negative 2, we should have an open circle. Now we want to test our points. So again, I'm going to pick a value that is less than negative 2, maybe negative 5, and I'm going to test it below. So I have 3 times negative 5 plus 3 over 2 times negative 5 plus 4, and we're hoping that this is greater than 0. So we have negative 15 plus 3 is negative 12. We have negative 10 plus 4, which is negative 6. Well, that happens to be positive 2, and 2 is greater than 0. So we know that everything to the left of negative 2 should be included. Now we need to test a point between negative 2 and negative 1. So it makes sense that we would use negative 1.5. So we have 3 times negative 1.5 plus 3 divided by 2 times negative 1.5 plus 4 greater than 0. So on the top, when I do 3 times negative 1.5 plus 3, I'm going to get negative 1.5. And on the bottom, 2 times negative 1.5 plus 4 is 1. So I know that if I have a negative over a positive, that this is a negative number. So this section should not be shaded. And I have to check the section to the right of negative 1. 0 is a great number here. So I have 3 times 0 plus 3 over 2 times 0 plus 4. And this is greater than 0. So I have 3/4, which is indeed greater than 0, or greater than 0. So everything to the right of this line should be shaded. So when I write my final answer, I'm going to start at the left and read. So I have parenthesis, negative infinity to negative 2. Notice it's an open circle, so it gets a parenthesis. Union, now this one's a dot, so it gets a bracket, negative 1 to infinity. And now you've seen how to find the answers for both a rational inequality and a polynomial inequality.